Hi, so this deck of cards was compiled to facilitate working through the MCAT-style passage, isothermal titration, calorimetry, and drug development. The H blank N enthalpy is the enthalpy change when 1 mole, okay? So that's going to be 1 mole of gaseous ions dissolve in sufficient water to give an infinitely dilute solution. So what type of enthalpy is this? That would be hydration, the hydration enthalpy. Hydration enthalpies are always N blank P. So what's this characteristic that they have? Negative. They're always negative. The increase in enthalpy accompanying the addition of a specified amount of solvent to a solution of constant pressure. So be mindful of that. The fact that this thing is going to be at constant pressure. Is enthalpy of D blank N. Enthalpy of D blank N. What type of enthalpy is it? That would be the enthalpy of dilution. What is normal body temperature under physiological conditions in degrees Celsius? This is something that you should memorize, okay? So try to memorize this. That's supposed to be a star. That would be 37 degrees Celsius. Standard state temperature in degrees Celsius is, now standard state has a specific pressure and a whole bunch of other stuff. So you should also memorize whatever these values are. And just by doing problems with them, they'll come to you naturally. So that would be 25 degrees Celsius, but in order to use it, most of the time you have to convert it to Kelvin, so also 298 Kelvin. And remember, in order to convert from degrees Celsius to Kelvin, you just add 293 degrees. It's really, 273. So you're going to add 273. It's really 273.15, but most of the time you can get away with 273 unless the answer choices are not spaced widely. They're like really close. You might want to use 273.15. The energy of formation of an element in its normal state is defined as, what is the value of this energy of formation? It's defined as 0. So the energy of formation for an element in its standard state is 0. And I think it's like denoted like that. And H, which stands for enthalpy, and this degree sign out in front of it, standing for standard. What is the equation for the first law of thermodynamics? What is the general equation? This is something that you definitely want to memorize as well. All right, here it is. Delta U equals Q minus W, where Q equals the heat released or absorbed by the system, and W equals the work done on, well, in this case, it's the work done by the system since it's negative. But if this were positive, because it could go either way if this, well, since this is a minus, the work done by the system would be positive. I think I'm confused. No, the work done by the system is negative. But if it were positive, the overall, if the overall function were addition, then it would be work done to the system or on the system. And delta U is a change in energy, specifically internal energy. And internal energy would be like the energy of the molecules at a molecular level due to collisions or whatever goes on at the microscopic level. When the heat flow is equal to work done, that's when Q is equal to W, the process must be iso what? Isothermal. That's because the delta U term goes away. It equals 0. So if the change in internal energy is equivalent to 0, that means that there's no temperature changes. Overall, it's staying the same from initial to final state. On a microscopic level, there might be changes, but overall, the average, is going to be 0. When the heat flow is equal to the work done, that's when Q equals W. It can be deduced that delta U equals 0 or blank equals 0. I think I just mentioned this to you. So what else is equivalent to 0? That would be delta T, again, the change in temperature. When the change in internal energy is equal to the heat flow, delta U equals Q, then there can be no blank done by or on the system. What cannot be done? All right, you've guessed it, there can be no work done on or by the system. The work term in the first law, that goes to 0. All right, this one is a mouthful, but it's just setting up the conceptual background. That's why there's all this verbiage. When the change in internal energy is equal to the heat flow of a system, that's when delta U equals Q, we saw that before, then there can be no work done on or by the system. We also saw that. Since work is PV work, and that W equals 0, there can be no change in volume. And the process must be iso blank. What is, when there's no change in volume, it's considered iso what? All right, so the process is isochoric. A lot of people are familiar with the terms isothermal for no change in temperature and isobaric for no change in pressure. But when there's no change in volume, the process is said to be isochoric. And blank process is one in which there's no heat exchange. That is the Q term in the first law goes to 0 between the system and the surroundings. What type of process has Q equivalent to 0 or no heat exchange. All right, this is like a weird word, has a lot of vowels. It's an adiabatic process. So for an adiabatic process, the Q term in the first law goes to 0, okay? And all you have left is delta U equals W.